In 1977, NASA launched a spacecraft the size of a small car and pointed it at the outer planets. The mission was supposed to last 5 years. It's been 47. If this is the kind of story you follow, subscribe to Bearman Stories. New mystery every week. Voyager 1 is now so far from Earth that a radio signal traveling at the speed of light takes over 22 hours to reach it. It has crossed the edge of our solar system, the first human-made object to ever enter interstellar space. And what it found out there, NASA is struggling to explain. Not because the data is corrupted, because the data is real. Voyager 1 was built to study Jupiter and Saturn. That was the plan. After swinging past Saturn in 1980, the spacecraft had enough velocity to keep going, forever. No fuel, just inertia, and the void. In August 2012, it crossed the heliopause, the boundary where the sun's influence ends and true interstellar space begins. No spacecraft had ever done this before, and the instruments on board started sending back numbers that no model had predicted. Anomaly number 1, the temperature. When scientists calculated what Voyager 1 would encounter at the heliopause, their models predicted a gradual transition from the solar wind into colder interstellar space. What Voyager found was the opposite. The plasma at the boundary was hotter than the surface of the Sunday, hundreds of thousands of degrees, in a region of space that, by every model we had, should have been cooling down. Nobody has a complete explanation for this. The leading theory involves magnetic reconnection, a process where magnetic field lines snap and release energy. But the math still doesn't fully add up. Anomaly number 2, the hum. In 2021, scientists analyzing Voyager 1's data detected something unexpected, a persistent, low-frequency vibration in the plasma of interstellar space. Not a burst, not a spike. A continuous hum, like a tone being played on an instrument we've never seen. The hum is consistent, it doesn't stop, and it's coming from everywhere. Plasma waves in space are normal, but a monotonous, unvarying hum across the interstellar medium, that was something else. Dr. Stella Koch-Ocker of Cornell University, who led the study, described the signal as weak but persistent. Scientists believe it's generated by the interstellar medium itself, but why, and exactly how, remains an open question. Anomaly number 3, the silence that almost ended the mission. In November 2023, Voyager 1 started sending gibberish, not static, not silence. Gibberish. Structured data packets that looked like they should contain information, but contained nothing coherent. For 5 months, the only spacecraft ever to reach interstellar space was effectively mute. NASA engineers spent weeks poring over decades-old documentation, some of it written before the internet existed, trying to diagnose a computer fault 15 billion miles away, with a 45-minute one-way communication delay. They eventually traced the problem to a corrupted memory chip in one of the flight data computers. The fix: reroute the code around the dead memory. Like performing surgery on a brain older than most of the surgeons. It worked! In April 2024, Voyager 1 started talking again, but here's what nobody fully explained. Before the gibberish began, Voyager 1's antenna, the dish that points toward Earth to transmit data, had quietly repositioned itself. No command was sent. Engineers confirmed this. There was no instruction from Earth, no scheduled maneuver. The antenna simply moved, on its own, and pointed toward a different patch of sky. Then the data went to gibberish. NASA's official position is that the antenna movement was likely caused by the same computer malfunction that corrupted the memory chip, a software error that triggered an unintended rotation. That may be true, but likely and may are not the language of certainty. And for a spacecraft 15 billion miles away, in a region of space no human-made object has ever traversed, certainty is a lot to ask. In April 2026, NASA made a decision that tells you everything about where Voyager 1 stands. They turned off one of its scientific instruments. Not because it was broken, because the spacecraft is running out of power. Voyager 1 runs on a nuclear battery that loses about 4 watts per year. To keep the most critical instruments running, NASA has been shutting down systems one by one. The instrument they turned off in 2026 was the plasma wave subsystem, the very tool that detected the interstellar hum. The one instrument giving us the clearest window into what interstellar space actually sounds like has been switched off. NASA estimates Voyager 1 has until approximately 2030 before it can no longer power any scientific instruments at all. After that, it will still be out there, moving at 35,000 miles per hour through the dark. In 40,000 years, it will pass within 1.6 light years of a distant star. No one alive will see it. No instrument will record it. It will just keep going. Here's what we know. Plasma hotter than predicted. A hum that doesn't stop. An antenna that moved with no command. 5 months of gibberish. And NASA turning off the one instrument that was giving us answers. Here's what we don't know. What exactly is in interstellar space? Whether our models of the solar system's edge are fundamentally wrong or just incomplete. And here's the question that none of the press releases ask out loud. If the boundary of our solar system is stranger than everything we predicted, hotter, louder, weirder, what does that say about what lies beyond it? Voyager 1 was built to answer questions about Jupiter and Saturn. Instead, it gave us questions about the universe. And 47 years later, we still don't have the answers. Bearman stories. Because the history they taught you has gaps. And so does the universe.